Hello students, hope you are doing well and you could follow the previous videos on gravitation. In this video, we are going to look at the following topics, that is gravitational potential energy. We'll try to understand what is gravitational potential energy, then gravitational potential, and what is the relation between gravitational potential and work done, or how do we use gravitational potential and potentials concepts to find work done. So let's try to understand gravitational potential energy of system of two masses. Now, under what condition gravitational potential energy of a system increases? Gravitational potential energy of a system increases whenever work is done against a conservative force. You're getting it? Like if I take a book and lift it, then what is happening? We say the potential energy of the book is increasing. So what is actually happening? Gravitational potential energy is increasing. Now, why is it increasing? Because the gravitational force is acting downwards and you're doing work against the gravitational force. And we know that gravitational force is conservative force. So the rule of increase in in potential energy, not only gravitational potential energy, any potential energy is whenever work is done against a conservative force, that work results in increase in potential energy. So here, what is the gravitational potential energy of system of two masses? It is work done in bringing the masses from infinity to their present distance, So let's try to get an expression for that. Now, what is the force acting between them? Force acting between them is given by G m1 m2 by r square, right? So work done, we know that it is integral f dot dr. So if work done is integral f dot dr from r1 to r2. So what is it? Work done equal to force is G m1 m2 by r square dot dr. I don't have to bother about dot because theta is 0 because the force is acting along the line joining them. R1 initial distance is infinity, final distance is r. So from this, what do I get? I get work done equal to, I can take out G m1 m2 outside. I'll be left with infinity to r dr by r square. So if I find the integration, I'll get G m1 m2 into minus 1 by r. Integration of 1 by r square is minus 1 by r, infinity to r. So I'll get work done equal to G m1 m2 into minus 1 by r. So minus G m1 m2 by this is equal to final potential energy. So this is change in potential energy actually, but initial potential energy is 0. So I get final potential energy of two masses is how much? G m1 m2 by r. This is what is the final potential energy. So not only this, for any situation, if I want to find potential energy, I can follow the same method. So we find what is the work done, and if the work is done against a conservative force, then the potential energy increases, and if the work is done in the direction of conservative force, potential energy decreases. Here the force is attractive in nature, so what is happening is the potential energy is decreasing. And there is one more general rule which will help you to find the sign of the potential energy. That is, if attractive forces in a system dominate, then the total potential energy of the system would be negative. And if repulsive forces dominate, then the total potential energy of the system would be positive. So this is about potential energy of a system of two. Now let's look at potential energy or gravitational potential energy of system of masses which are more than 2. Here as an example, we are taking a multiple mass system. There are 3 mass system. Let's say the separation between them, I'll take it as A. So 3 masses are placed on the vertices of an equilateral triangle. What is the potential energy of the system? So here the easiest way is I can just take potential energy of this part, potential energy of this part, and potential energy of this part and add them. Because potential energy is a scalar quantity, I don't have to bother about the directions. So I can say the total potential energy equal to minus G m1 m2 by A plus minus G m2 m3 by A plus minus G, let's say m1 m3 by A. So in this way the potential energy would be minus of G m1 m2 by A plus G m2 m3 by A plus G m1 m3 by A. Right? So all the 3 possible combination. Now if I want to extend the same idea to a square, let's say I have a square having 4 equal masses on the vertices and I take the side of the square is 8. Then what is potential energy of the system? Now I can see that there are 4 masses which are having a distance a between them. So due to this 4 combination, I can say directly potential energy is 4 times gm square by a with a negative sign. Now there are 2 combination which have diagonal distances. So I can say minus of 2 into gm square by root 2a. So this is the total potential energy of a square. That means if I have a system of masses, I have to take into consideration all combinations that are possible and find the total to find the potential energy of a system of masses. So if I want to find the number of combination, I can use the rule NC2. So combinations rule, if there are n systems, 2 taken at a time, then the total number of combinations would be NC2. That would help you to check whether the answer that you got is correct or not by checking whether you have considered all the combinations or not. After that, let's look into gravitational potential. Now, gravitational potential at any point in the gravitational field of a mass is the work done in bringing a unit mass from infinite distance to that point, right? So, gravitational potential energy takes into consideration effect of 2 masses, at least 2 masses or system of masses. But when I talk about only one mass, I want to find what changes this mass is causing. Then I take this mass and bring another test mass from various points to check what is the effect. So the potential would be the potential energy of the system when a unit mass is brought there. So how can I write the potential? Let's say this point I'll call it as potential P. Now potential at P is equal to how much G? I'll call this as capital mass M. G M into other mass is 1 by R with a negative sign. So potential at P would be equal to minus G M by R. This is gravitational potential due to a point mass. If it is not a point mass, the distance would be considered from center of mass as usual. Got it? So if I want to find what is the units of potential, potential unit is I am dividing the total energy by mass. So units of gravitational potential. Now gravitational potential is denoted by Vp, or potential is Vgp. P is the point, I can say Vg. So SI units would be equal to energy per mass, so that is joule per kilogram. And now if we have a system of masses, like I have one mass here, m1, m2 here, m3 here, I have a point P here at a distance r1 plus from here r2 from here r3 from here, then the potential at P would be equal to minus gm1 by r1 minus gm2 by r2 minus gm3 by r3. So the sum of potentials due to each mass would be considered for finding potential at a particular point. And because potential is a scalar quantity, I don't have to bother about directions. I can directly add them. Now let's look at gravitational potential due to Earth. So gravitational potential due to Earth at on the surface is equal to how much? Minus gm by re. Now potential due to Earth at a height h would be equal to how much? Minus gm by re plus h. Now we use this concept of potential to find work done or energy necessary for a body to move from one point to other point. Now what is work given by? Work can be given as final potential energy minus initial potential energy. So this can be written as final, if I take out m outside, final potential energy potential would be gm by re plus h minus gm by re, if I am taking it from the surface of Earth to some other point with a negative sign outside. So in this way I can find out what is the work done. So that we'll be discussing in the next slide. Now let's see. I want to move a mass m from the surface of Earth to, let's say, a height h. I want to find what is the work done. So I can say work done in moving a mass from surface of Earth to any other point is mass into potential on surface. I'll say potential on potential at a height h minus potential on the surface. Mass into final potential minus initial potential. Now what is potential at a height h? Minus gme by re plus h. And what is potential on the surface of Earth? It is minus gme by Re. So work done can be given as, if m is the mass, m into minus gme by Re plus h minus of minus gme by R. So that would give me m into gme, I'll take it out, I'll be left with 1 by Re minus 1 by Re plus h. This is the work required. Now let's take the value of height. So let's say I want to find work required to take the body from the surface of Earth to a height 2r from the surface of Earth. So in that case, what will be energy? Gmem remains same. Now this would be 1 by Re minus Re plus 2Re would be 1 by 3Re. So that would be equal to, if I take 1 by 3Re outside, I'll be left with 2Gmem by 3Re. This is the work required. Now don't use mgh, because delta PE equal to mgh. This is only valid when h is very small, very close to surface of Earth. Because if you use mgh, you will see that m into g into 2r would be the answer, which is not equal to what we have got. So mgh is used only when h is very small compared to the radius of Earth. So let's have a quick review of what all things we have seen. We have seen what is gravitational potential energy. The work done in assembling the system of masses is stored as gravitational potential energy of the system, and we have seen that gravitational potential energy is negative because always gravitational force is attractive in nature. And then we have seen what is the relation between work and gravitational potential. Before that, we have even defined what is gravitational potential. So gravitational potential is always due to one mass. And how do I find it? It is equivalent to work done in bringing a unit mass from infinite. Infinity is a point outside the field of the mass to that particular point. So this is what is there in gravitational potential energy, potential, and how we find work using potential. Hope you could follow this. Thank you very much, and keep watching other videos of concepts as well as questions that are required for your competitive exams at Get My Class. Thank you very much.